Hi, I'm Cassie, and I'm going to walk you through question 50 of the AAMC's official physics question pack to help you prep for the MCAT. So this question is still related to passage 8, which is all about lenses and mirrors, and specifically it's testing your understanding of Snell's law, which is a super important, heavily tested concept on the MCAT. So let's get right to it. So instead of drawing the more complicated diagram that we give us, I'm just going to focus on the simple idea of what's going on, which is that we have a border, an intersection between two mediums. We have air first, and then we have glass below it. So this represents the border where the ray is transitioning from the air into the glass. So let's say our ray of light here is going at this angle. So it goes to that intersection between the two mediums, and then what's going to happen? Well, remember with any of these Snell's law problems, we always want to draw our normal, which is just going to be a dotted line that's perpendicular to our surface here. So this is our normal line. And notice we have an angle theta here, which we're going to call theta I, which is the incident angle, the angle that the light ray is hitting that transition between mediums at. Now what's going to happen when the ray transitions from the air to the glass is that glass is a lot more optically dense than air. So all of those particles in the glass are going to sort of slow down that light ray, which has the effect of making that light ray appear like it's bending in the glass. And to know how much it's going to bend, we need to know the index of refraction of each of these two materials. So something you should have memorized for the MCAT is that the index of refraction of air is 1. Easy enough to memorize, right? N equals 1. Now the index of refraction of glass isn't given to you in the problem, but you should know that it's going to be greater than air. So it's going to be about 1.5. But you didn't need to know the specific number. You just needed to know that glass is going to be more optically dense than air. So when we transition from a medium with a lower index of refraction to a medium with a higher index of refraction, that light ray is going to bend closer to the normal. So our new theta, our angle between our normal and our light ray, we're going to call theta r for our refracted theta. And what do we know must be true? Well, we know that theta I, our incident angle, is bigger than our theta r because it bent towards the normal. And there's a good mnemonics to help you remember this, FAST, FST, which is that when we go from a medium where light travels faster, like air, for example, to a medium where light travels slower, like glass, then our light ray is going to bend towards the normal. Okay, so that's the concept behind Snell's law, but clearly our answer choices are telling us that they want some sort of equation. So in terms of an equation, our actual equation that you should have memorized for Snell's law is going to be N1 sine of theta 1 is equal to N2 sine of theta 2. So what does this mean? Well, N1 is going to be the index of refraction of our first medium the light is traveling through. So in this case, that's going to be our index of refraction for air here. And then theta 1 is going to be our angle, our incident angle, so this first angle here. And we're saying that that is equal to the index of refraction of our second medium, which is going to be, again, our glass here, so about a higher index of refraction, times the sine of our theta 2, which is going to be our refracted angle here. So the correct answer here is going to be C, because C is just giving you the equation for Snell's law. So this equation is really useful. Like, say I knew my angle of incidence was 25 degrees, and I wanted to solve for my refracted angle. Well, then I could just go ahead and plug in numbers, right? I could say, okay, index of refraction is air, so I'd have sine of, we said theta 1 is 25 degrees, equals my index of refraction of glass, which is 1.5, times my sine of theta 2, and then I would just go ahead and solve this and figure out what theta 2 is. Now, this is an awesome question. I hope you get it on your MCAT, and you probably will get at least 1 or 2 questions like this that are what I call kind of throwaway questions. If you know the definition of Snell's law, it should take you 5 seconds to answer this question. So make sure to review your equation deck after this so you can get these freebie questions, but also not just memorize the equation, because while you might get 1 or 2 freebie questions like this, most of them are going to be testing your ability to either plug into this equation or even more commonly understand the concepts behind what is Snell's law, what is refraction, the bending of light, etc. So I hope this helps. If this helps, please give this video a like and follow my channel for more content like this.